Hi again, welcome to the last video of the third chapter of A-level physics, which is dynamics. And in this video, we're going to be tackling P2 topical questions. So let's begin. A jet of water hits the vertical wall at right angles, right? This is hitting at 90-degree angle. So horizontal jet density of water, cross-sectional area, this area, right? This area, velocity, and the water runs down, right? So the reason water runs down is not because of a force applied or anything, right? It's just because of gravity, right? It has nothing to do with the force being applied because of the wall. That is the first thing you need to realize, is that if it were a force applied by the wall, it would go backward, right? So it's just stopping here and going downwards. So the water runs down. Show that over a time of 1.6 seconds, the mass of water hitting the wall is 1.2 kg. So the first thing that you need to realize is this is the formula you need to apply to get the mass, right? Density times volume is equal to mass. Now we know the density of the water, but we don't know the volume. So let's just draw a structure here so it's very clear to you guys. Now this area right here, this is a cylinder, right? So the formula is cross-sectional area, base area, times height. Now the area is this one, 1.5 times 10⁻⁴ meters. And the height can be found using the velocity formula, because a velocity and time is given, right? Velocity and time. So velocity is equal to distance, which would be height in this case, into time. So this would come here. So the velocity 5 would be multiplied by 1.6 seconds, right? So this would become the expression for volume of this water. So the density is 10 times 3, right? And the volume now becomes 1.5 times 10⁻⁴ times 5 times 1.6. And this comes down to 1.2 kg. So this is our answer. Calculate the decrease in the horizontal momentum of the mass of water in A due to hitting the wall. Decrease in horizontal momentum. So as I said before, that this horizontal velocity of 5 becomes 0 and it runs down the wall, right? So the decrease in momentum is basically the momentum before is some momentum and the momentum after is 0 in terms of horizontal, right? So delta momentum is equal to final, which is 0, minus initial. So 0 minus, and this is 5 into 1.2. So this becomes 6 Newton seconds, right? So this is the change. The magnitude of horizontal force exerted on the wall. Now this is the equation we're going to be using for this one. 6 over 1.6. So this becomes 3.8 newtons after rounding it to one decimal place or two significant figures, because everything is in two significant figures in the question. State and explain the magnitude of the horizontal force exerted on the wall by the water, right? So we know that the force exerted on the water by the wall is 3.8 newtons, right? So this would be the same, but in the opposite direction. We just need to show the magnitude, right? Not the direction. They have specifically asked you to explain the magnitude. So just explain the magnitude, that 3.8 newtons because of Newton's third law. And you can even explain the third law if you want, that the force is equal but in the opposite direction, but that is not required in the 1 mark question. You can do this in the paper if you want extra time. State the principle of conservation of momentum. So in a closed system, right? Closed system is very important to say. The total momentum before collision is equal to total momentum after collision. Now the two balls X and Y move along a horizontal frictionless surface as shown from above. Now this is just telling us the angles and velocities that is shown here. The balls collide and stick together. Now a very important thing in tackling these questions is the balls sticking together. Now whenever in a collision, when two objects collide or three objects or however much, and if they stick together, their mass is mx plus my, right? You just have to consider them as one particle, right? With masses is as the sum of where the mass, which is the sum of the two masses, right? So let's just use this to solve our question along the line AB by considering the components, right? They even tell you how to solve the question sometimes. Components of the momenta along line AB, calculate theta. Now, momenta along the line AB. So we have to consider the momentum of horizontal directions, right? We can even solve this considering the momentum of vertical direction, adding them up and equating them to 0 because the vertical component is 0 here. But the question specifically asks us to consider this about the direction line AB. So we are only going to consider horizontal momentum. So initial momentum is, this is both in positive directions, right? So just write it as positive. Initial momentum is 3 times 4 plus 2.5. No, I'm just doing something wrong here. Initial momentum is 3 times 4 cos theta, right? Cos theta, because that is the component of speed that is being applied. 4 cos theta plus 2.5 times 4.8 cos theta. Now this expression is equal to this 3.7 times 5.5, right? Because that's the mass of these two particles. 5.5 kg, right? It's just the addition of these two masses, right? Initial momentum, horizontal momentum, is equal to final horizontal momentum, right? So let's just solve this. 12 cos theta plus 12 cos theta is equal to 20.35. Now theta becomes cos inverse 20.35 divided by 24. Just solve this. I'm just skipping a step here. So the answer here becomes somewhere close to, theta becomes 32.014 and something, right? Now the answer you can give in 1 or 2 significant figures, right? So let's just write 32 degrees here as our answer. Now the third part says that by calculating kinetic energy before and after the collisions, state whether the collisions are elastic. I'm sorry about this. This should say collisions, right? Whether the collisions are elastic or not. So you know that the two things that you need to know about elastic collisions is the Ke is conserved and relative speed of approach is equal to relative speed of separation, right? So again they are telling you how to get the answer. So let's calculate the kinetic energy here first. 3 times 1 by 2 mv square. So 1 by 2 times mass 3 multiplied by 4 square, plus, because this particle is also moving, 1 by 2 mv square, right? So this comes down to 53 joules, right? 53 joules. Yeah. And now the final kinetic energy is 1 by 2 times 5.5, right? Because we've discussed to treat it like one particle, times 3.7 whole square. And this becomes 38 joule. Now you can see that the kinetic energy is decreasing across the collision, right? So you have to say that the collision is inelastic because Ke changes or decreases during the collision, right? During or after or whatever, during the collision. Moving on. The last part now. A stationary nucleus P of mass 243U decays by emitting an alpha particle of mass 4U, right? To form a nucleus. Now I'm just going to tell you that the mass here is 239U, right? You don't need to know what U is right now. Let's just say it's a unit right now. It's a unit of mass when concerning the mass of nuclei, right? So the initial speed of this, use the principle of conservation of momentum to explain why the initial velocities of Q and the alpha particle must be in the opposite directions. Now, if they have to move somewhere, they have to move in the opposite directions. Otherwise, momentum is being created, and that's just cannot be done, right, in a closed system. So this is the nucleus P, and it is stationary, right? So its V is equal to 0, so momentum is equal to 0. Now, a alpha particle starts moving away from it, so it has to move backwards to balance out the momentum that is being created in the right direction, and it goes in the opposite direction, which is the left. So the principle of conservation, so sum of initial equals sum of after, right? So initial was 0, right? Initial momentum was 0. Thus, if alpha moves to right, Q needs to go in the opposite direction to balance or to cancel. You can even write balance to cancel the momentum and maintain total momentum is equal to 0, right? 0. Determine the initial speed V of nucleus Q. So this is very easy. E0 initial is equal to after. So 1.6 times 10 7 multiplied by 4u plus 239 u multiplied by negative v, right? Because it's in the opposite direction. So this just becomes 1.6 times 10 power 7 times 4u is equal to 239 u negative 239 uv, right? So v becomes 1.6 times 10 power 7 multiplied by 4u divided by, negative v becomes 239u. Now the u cancels out because they are multiplying, so you don't need to concern yourself with the u here. Just calculate this. Now after rounding off, let's just write it like it is. 2, 6, 7, 7, 8, 2, and some decimal places. Now you know that the velocity is in the left direction, so this is why it's negative here, right? So let's just ignore the negative and just round this off to two decimal places, two significant figures, like it is given in the question. So 2.7 times 1, 2, 3, 4, 5. 2.7 times 10 raised to the power of 5, right? So this concludes our P2 topical and our chapter. I hope you enjoyed and learned dynamics. Again, I'm going to tell you to practice some of these questions by yourself from your topicals, right? So that you have a better grasp on the topic. Thanks for watching and goodbye.